So here we are, talking about the tides. Tides are driven by an imbalance of centrifugal and gravitation forces. At the Earth's surface, only the Sun and the Moon create oceanic tides. Other planets are too far away. Okay, so now the important bit. The tidal force imposed by the Moon and Sun can be described by a set of individual tidal constituents, each described by a specific wave period. So all that the astronomical forcing does is to create waves of a specific period. Not only one, but a set of waves. It does not prescribe the wavelength and does not prescribe the amplitude. Okay, and you already know that the wavelength is influenced by the total water depth. Okay, it's the total water depth. In the deep ocean, it's 4,000 meters. On continental shelves, it's 100, 200 meters. Okay, and the amplitude is the response of, it's the result of resonance. Resonance, how well the period actually fits the period of natural oscillations on Earth. Okay, however, now what we can do is we can exactly say what are the periods of these individual tidal constituents. So the tides produced by the Moon, the key parts of it is the M2, which has a period of 12 hours and 25 minutes, and the O1, which is a diurnal lunar tide. Lunar means coming from the Moon, 24 hours and 50 minutes. Twice that of the semidiurnal. Why isn't it exactly 12 hours or 24 hours? It's because while the Earth rotates once, okay, the Moon also moves a little bit, and to actually get exactly the same configuration, you have to wait for another 25 minutes for the semidiurnal. Why do you get semidiurnal tides? That's, you have to look at, it's a combination of two factors. You have to look at the distribution of the gravitational force and the centrifugal force, and it's always, you get actually two bulges, two centers where you have a high tide. One is under the region which is closest to the Moon location. This is where the gravitational force is bigger than the centrifugal force. And on the opposite side of Earth, where the centrifugal force exceeds the gravitational force. Okay? Anyway, so also you get tides produced by the Sun. One is 12 hours. Semidiurnal means you get two peaks per day, two high tides per day. And the diurnal solar is 24 hours, called K1. Hooray! So this is what you have. Now regions respond totally different. Different regions respond totally different. Let's have a look at some time series of tides. Okay? Have a look at the time of different regions. Okay, here are 4 examples of tides, and all over one lunar cycle. Okay, from one full moon to the next full moon. All right, and you can see the sea level goes up and down and up and down, and this is what we talk about. Water moves in and out and in and out, and the sea level goes up and down and up and down. But the tidal range changes over time. Tidal range is from the top to the bottom of these oscillations. Okay, and you can see there, I just activate the laser. Here we are. Here's the region where you have the maximum tidal range, and then some 2 weeks later, you have a time where the tidal range is smaller. Okay, this is for Liverpool, and in this region, it's mainly semidiurnal tides, 2 peaks per day. So, and why do you get now these variations of the tide? This is called the spring neap tide cycle. Okay, and you always get the maximum if the sun and the moon and the earth are all located in one line. Doesn't matter on which side the moon is, just on one line gives you this maximum tidal force. And I show you this animation. This is essentially just a simulation. You get spring tide whenever they are in one line, and you get the neap tide at the when the moons is. This is for the half. For the first and last quarter, I think it's called. Okay. All right. This is good. No, I forgot something. Hang on. You can see in this time series also some other patterns. And this one looks very much like some of the simulations that I just showed you. Look at this weird pattern. This is the interference of two constituents. Sometimes there's a third tidal constituents. I showed you that there are 4, okay, but often it's only 2 that make up a signal. Look at Hondao. Here, all of a sudden, you only have diurnal tides. Where are the semi-diurnal tides? Your neighbor comes and says, "Oh, I went to Hondao, and there are no semi-diurnal tides. Someone took them away." So why are there no semi-diurnal tides in Hondao? Why are there no diurnal tides in Liverpool? That's weird, isn't it? So why? Okay, we answer this question. We're going to answer this question.